So I'm going to have a go at Leetcode problem. It's number 37, called Sudoku Solver. So we need to write a program to solve a Sudoku puzzle by filling the empty cells. A Sudoku solution must satisfy all of the following rules. Okay, so it's standard Sudoku. We need the digits 1 to 9 in each row, column, and 3 by 3 sub-box. The dot character indicates empty cells, and the input is an array of characters consisting of the numbers. So we have 5, 3, empty cell 7, etc. for each row, defined as an array, a 2D array of characters. And the output is also a 2D array of characters. The input board is shown above and the only valid solution is shown below. Okay, I'll assume that's right. So constraints, the board length is 9. The length of each row of the board is 9, so it's a 9 by 9 grid. And every character in board, which is the input array, is a digit or a full stop to represent an empty cell. It's guaranteed that the input board only has one solution. Okay, so I'm going to do it in Java. So let's have a go at that. Okay, so here is the grid. I think the way to do this is going to be to brute force it. So to work through our cells and just try, for the first empty cell we find, try a number. So I'll try the number 1. Now I need to check if that number is valid. So will it fit in the row, column, and 3 by 3 box? And in this case the number 1 does. So then I'll move on to the next cell and try a number. Now for each cell I'm going to loop through every possible number. So I'll think about number 1. Can I put number 1 in? I can't, because it's in the row and it's in the column and it's in the 3 by 3 box. So I'll move on to 2. Can I put 2 in? I think I can. Move on to the next box. Can't put 1 because it's in the row. Can't put 2, it's in the row. Can't put 3, it's in the column. So I'll put 4. And then this one, can't put 1, 2, 3, 4, 5 in the row. 6 in the box. 7 in the row. Try 8. And this one, can't put 1, 2, 3, 4, 5, 6, 7, 8. So put 9, and I think at this point we're going to get stuck. So here, can't put 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we're stuck. So now I'll take a step back. And because I've already been through the whole loop there, I need to take another step back. What I'm going to do, it's going to be recursive. So at this point I only got up to 8. So I'm then going to try 9 here. It's obviously not going to work because here the only valid digit we can get is 8. Then on this one, we'll go through the whole loop. We can't do anything. So backtrack the 8, backtrack the 9, and backtrack the 4. Here we then try 5. I think the way to do it is to look through the empty squares and put the first number in that empty square that we can. And then recursively do the whole thing again. In other words, so once we put the 1 in that box, we'll start again here and try and put a 1. We can't. Try and put a 2. We can. And then when we put a 2 in, we'll start the whole thing again here. Can we put a 1? No. No 2, no 3, 4. And keep going like that. But if at some point we get to a point where we're stuck, there's no value that can go in the box, we'll just go back to the previous step and carry on with the for loop. So if I couldn't put a value in here, I would undo that 2 and put a 3 in. If I couldn't put a value in there, undo the 3, try 4, until we so we'll go through. It's not going to be particularly efficient, but I don't think there's any other way of doing it. So I'm going to do it in Eclipse. The first thing I'm going to do, I think we're going to have a few different methods in here. So I'm going to save the board to save passing it from method to method. And then I'm going to have a recursive method. So this method is going to call itself. I'm just going to solve that. Call that solve. So I'm going to call solve. Now I need to loop through the grid, looking at every square. So I'm going to say for int x equals 0, x is less than size x plus plus, and I'll define size as 9. I don't suppose we're ever going to worry about resizing a Sudoku board, but it's just good practice to define that there. The reason it's good to define size, I should probably call it board size, but if we're looking through the code again later and we see x is less than 9, we might wonder, what's that 9 about? And similarly, I'm using x and y to represent an xy coordinate in the grid. Now, if board x, y is not equal to dot, if it's a dot, it's no, sorry, if it is equal to dot. If it's a dot, it's an empty square and we want to consider it. Now, for each value, for each candidate value, so I'm going to call it candidate from 1, its character. I can treat characters just like numbers. Char character equals 1. Character is less than or equal to 9. So for the values from 1 to 9, the character values, candidate we're going to try that candidate in that board. So board x, y equals candidate. Now, if the board is valid at this point, to tell if the board is valid, actually I think it's going to be better to say if that candidate fits in the board. So if candidate fits, I'm going to write this method candidate xy. Now I'm just going to add that method. I'll just return false for now. So if the candidate fits into the square of the board, and when I say candidate fits, I mean if it's not already in the row, column or 3x3 box, then we're going to put it in. And this solve method, I'm going to make it return a value. This here, when we put the candidate onto the board, I'm going to return the recursive call of itself. So there I've put the character in, and then I'm going to recursively call the method. If we get to the end of all the characters and none of them fit, I'm going to return false. If we get, so we're going through the board. If we found an empty square and we've got through all the characters without returning true from a recursive call to solve, then I return false. But if we don't find any characters on the board, in other words, we go through this whole for loop and the x and y for loop, and the board doesn't find any characters and any empty characters, we've done it. So we return true. So this point means we found an empty square, but we couldn't find a candidate to fit it. So that is false at that point. Here I need to say if not solve, then undo what I've done. I'm not sure that that's right, but I'll debug it. Let me just go through it once more. We go through the grid. If we find an empty square, we go from 1 to 9. If we find a character that fits, we put it in and we try and call solve. If we don't solve, we undo that character and then carry on with our loop later. If we get to the point where there's an empty square but we can't get a candidate into it, we return false. So in other words, that would come back to here and it would undo and carry on. If we get to the point where we've been through the whole board and we haven't found any empty characters, we return true. I think it's right. Candidate fits. Okay. I'm going to loop from int row equals 0, row is less than size row plus plus, and I'm going to say if board at row y equals candidate. Actually, I'm going to call this I. If board at row I equals candidate, then candidate doesn't fit because the character is already in that column. And similarly, if it's in the row, return false. Now for the 3x3, I'm going to say int base x equals x over 3 times 3. So what I'm saying there is this. So this is index 0, 1, 2, 3, 4. We don't need to go any further. So 0 over 3 is 0 times 3 is 0. So 0 would lead us to row 0. 1 over 3 is 0 times 3, 0. 2 over 3 is 0 times 3, 0. 3 over 3 is 1 times 3 is 3. So that's going to point here. So so for each value of x, I'm getting the left hand side of the box. I'll also do the same for the y to get the top of the box, and then we could do a 3 by 3 loop to look at the values in the box. So base x is x over 3 times 3, base y is y over 3 times 3, and then for int x equals 0, x is less than 3. I suppose this kind of, I can't use a size. I could do size over 3, but yeah, I'll just leave it. X is 0, x is less than 3, x plus plus. We've already got an x. So for row is 0, row is less than 3. Well, in fact, row equals, oh no, I'll do it like that. For column equals 0, less than 3, plus plus. If board base x plus row and base y plus column equals candidate, return false. If we get to the end of this method, we haven't found it in the row, the column or the box, return true. It's a valid candidate. So I need, at this point, I need to print out the board because I'm going to have no idea what's going on. So I'm just going to loop over the board. And system out print without print line board at x, y plus a space, and then here system out print line. So I'm saying there print the value at x, y and a space just so we can see it, and here print a new line. So that should give us some representation of the board. Now back to the example. Here is the input. So public static void main of course it's in completely the wrong format. Okay, so there's our board. Of course the exercise description wasn't for any specific language, so I've had to format that. Now there's our board. Now I need to do solve Sudoku, new solution, solve Sudoku with board, and let's see what it does, if it works. Okay, it's left the grid empty. Have I done that in the right place? I have, and it totally just hasn't done anything. Okay, if a call to solve is successful, I think we need to return true. Let's see what that does. Yeah, that fixes it. So if we cannot solve, we undo our trace. Otherwise, we return true. At this point in the stack, we are successful. So return true to the call-in method. And then when we finished our solve, the whole stack on every square, on every... Would it be every square? Every empty square that we found and we recursively called into will have returned true. Do we need this return true here? We need this return true here in case we're given a board which is completely populated and we don't get into there at all. So let's try that, and that seems to be working. Let me just, is that valid? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. That appears to be valid. I'm going to submit that. And see if it works. I don't need the main method and I don't need the output. Run it. Accepted and submit. And it's there. Beats 68.7%. Well, I'm happy with that. So that's how to do Sudoku solve with a brute force method. I hope that makes sense. I know it may have been a bit confusing because I was a bit confused myself when I was explaining it, but I think basically the idea is you just try every number. If that number fits, you start all over again and recursively call the method to get the next square to try every number. If you get all the way to the end of the grid and every number is solved, you return true all the way back through and you've done the job. If at any point you cannot find a number that fits, you return false and then the previous number will go on to try the next number. So that's basically the idea, and it's done with a recursive method. So I hope that makes sense. Thanks for watching.